Students, in lesson 5.3, we are going to be working on estimation. Remember, the reason why we work with estimation, it allows to check the reasonableness of our answer. So our essential question, which is going to guide our understanding and learning, is how can you estimate decimal quotients? And remember, keep in mind, quotient is the answer in a division problem. So we are going to start with the real world, unlock the problem. Carmen likes to ski. The ski resort where she goes to ski got 3 2/10 feet of snow during a 5-day period. The average daily snowfall for a given number of days in the quotient of the total amount of snow and the number of days. You can estimate decimal quotients by using compatible numbers. So boys and girls, there's a lot of stuff going in the problem, so I want to make sure we break it down into more manageable parts. When you hear the word average, average means the mean. So what you're going to do is you're going to have to figure out some days it snows less, some days it snows more. But the average daily snowfall for a given number of days, and I'm going to put in parentheses mean, and then I'm going to put above that is average. They say it's equal to the quotient of total number of snow and the number of days. So that's going to be important because we want to keep that in mind for how to figure out our answer. So now what it says to do is we're going to estimate the average daily snowfall. So we can estimate decimal quotients by using compatible numbers. And when choosing compatible numbers, you can look at the whole number part of a decimal dividend and rename the decimal dividend as either tenths or hundreds. So boys and girls, let's look at what we have first. We first got 3 2/10 divided by 5 because it's a 5-day period. So Carly and her friend Marco each find an estimate. Since the divisor is greater than the dividend, they both rename 3 2/10 as tenths. So in order to rename it as tenths, we're going to have to multiply by 10. Now, boys and girls, we're going to gain 1 decimal place, and we're going to move to the right, and we get 32 tenths. Keep in mind, you might say, how do I know that I multiply by 10? Well, you multiply by 10 because it says tenths, and you think about that as being 1 place value. Next, we have Carly's estimate and Marco's estimate. So 30 tenths is close to 32 tenths and divides easily by 5. So we're going to use the basic fact to find 30 tenths divided by 5. 30 tenths divided by 5, boys and girls, would give us 6 tenths or 6 tenths. Now, boys and girls, we're going to go to Carly's estimate. So the average daily snowfall is about 6/10 foot. Now, Marco's estimate is on the other side of this page. This estimate here, 30, was a little low, so I'm going to put down that it was a low estimate. And we're going to see that the estimate here, it's a little bit higher, so we're going to call this the higher estimate. This is something that we've practiced before with whole numbers, so I think it'll be something that you remind yourself of. So boys and girls, 35 tenths is really close to 32 tenths, and it divides easily by 5. So we're going to use the basic fact, 35 tenths divided by 5, which is 7 tenths, or in decimal form, 7 tenths. So the average daily snowfall is about 7 tenths foot. So we know between the two boys and girls answers, the answer is between 6 tenths foot and 7 tenths foot. Hers is a little less because her estimate was a little less for her dividend, and his is a little bit more because his estimate for his dividend was a little bit more. Next, boys and girls, it's asking us to see whose estimate do you think is exactly closer to the exact quotient, and explain your reasoning. So boys and girls, if I go back here, I see that 32 is really close to 30. It's only 2 off. 35 is 5 more, I'm going to say that Carly's estimate is closer to the actual. So I'm going to put down that Carly's estimate, because 30/10 is closer to 32/10 than 35/10 is, and they use the same divisor, which in both cases was 5. So keep in mind, I liked 32/10 because it was really close to 30/10. It was only 2 more. 35/10 is a little higher because it's 5 more tenths. So now, boys and girls, we're going on to number 2. It says, explain how you would rename the dividend 29 and 7/10 divided by 40 to choose compatible numbers to estimate the quotient. So, boys and girls, first step, I'm going to rename this as tenths. So right now, I'm going to take 29 and 7/10 times 10 tenths would give me 297 tenths. So what I'm going to say is I would rename 29 and 7/10 as 297 tenths. Then, boys and girls, then I would find compatible numbers that divide easily by 40. So boys, right off the back, I knew that a compatible number, I can say to myself, well, I can say 280 divided by 40 would give me 7. And remember, 40 is our divisor, and it's the same here. Or what I could do is I could go a little bit higher, and I could say 320 divided by 40 would give me 8. And notice, boys and girls, I'm really just using my multiples of 4, which we know are related to our multiples of 4D. If it helps you to think about it, you can say to yourself, 8 times 40 is equal to 320, or boys and girls, you could think to yourself, 7 times 40 is equal to 280. Remember, the dividend is always the product. Again, remember, the dividend is always the product in a multiplication problem. Those are the related multiplication facts. So boys and girls, we're going to go on to the next problem, which is estimate with 2-digit divisors. So we're going to build upon what we did before and get a little bit deeper into our understanding. So it says, when you estimate quotients with compatible numbers, the number you use for the dividend can be greater than the dividend or less than the dividend. So we can use the symbol greater or less. That's key because that kind of helps us when we're thinking about our estimation. So we're going to start with our example where it says a group of 31 students is going to visit the museum. The total cost of the tickets is $144.15. About how much money will each student need to pay for a ticket? We know that $144.15 is our dividend because that's what we're going to divide up because we need to find out the cost per person. How many people are on the trip? 21 students, which is our divisor. So boys and girls, step A, we're going to use a whole number greater than the dividend. So we use 30 for the divisor because it's a nice compatible number, and then we find a number close or greater to $1.04 that divides easily by 30. So we know that 150 would be a good number, because keep in mind 15 divided by 3 would give us 5. So we know that the compatible number of $150 divided by 30 would give us $5 per ticket. And notice, boys and girls, one place value minus one place value equals 0 place values. So that's why it's going to be $5. So each student would pay about $5 per ticket. Next, boys and girls, it says B. A different strategy is we can use a whole number that is less than a dividend. So what we're going to do is we're going to use the divisor 30 here, and then we're going to find a number that is close and less than 144 that evenly divides by 30. So boys and girls, if we think to ourselves our tables of 3, we just used in our last one 15. We're going to go less than 15. A multiple less than 15 of 3 would be 12. We know that 12 divided by 3, boys and girls, is equal to 4. So we can build back up to a larger number. 120 divided by 30, boys and girls, would give us $4. So each student will pay about $4 for a ticket. Now on number 3, boys and girls, it asks, which estimate do you think will be a better estimate to the cost of a ticket? Explain your reasoning. Now, boys and girls, because we're dealing with money here, we want to make sure that we have enough of money, not less money. So in this particular example, boys and girls, we would want our estimate to be a higher estimate. And what you're going to do with that, boys and girls, is you're going to use, think to yourself, money, I want to get a higher estimate. So the $5 estimate is better because the greater estimate will make us sure that we have enough money. If we don't have enough money, boys and girls, for the tickets, that's going to be a problem, because that means that someone's going to be left out. So for this one, we want to go with the greater amount.